All right, then let's begin. So last time we did the session, we were talking about forces and force components. هالمرة we will be talking about moments. So what do we mean by moment? زين. إحنا الحين when we have an object or any item, or let's say we have a beam, okay, a straight beam. زين متلصق في طوفة يعني. نفس shelf or beam or whatever. زين it's stuck to a wall. We might have يعني books on it or something that is applying a force. يعني مثلا عندنا كتاب كذي زين gravity is acting upon this book, so there's going to be a force acting downwards. تمام? So this force is obviously there's a reaction force from the flat shelf, you could call it, let's call it a shelf. That is, the reaction force. Usually we don't write this reaction force or normal force. That's what we usually call it. And then the normal force that keeps up the book. However, الحين, what about the shelf itself? What's keeping up the shelf? زين the shelf, it is connected here either by bolts or by screws. زين يعني متلصق في الطوفة بطريقة ما أو glue or whatever. زين so it's stuck to the wall in some way. All right, and the way this force when you act إذا حطيت وزن زيادة وزيادة وزيادة يعني if we added more books to the same shelf, sometimes we'll notice that the shelf starts curving downwards من كثر ما يكون فيه وزن. يعني if we added more books and more books and more books, the weight of it will cause it to start bending. زين bending. So this bending is what we call moment, a moment of something around a specific point. فالmoment, or sometimes they call it bending moment, يساوي الفورس times perpendicular distance d. And this moment, sometimes it has no effect. يعني it cancels out based on how secure this is or how heavy the material is أو إيش كثر ثابت يكون. But sometimes it causes a little bit of bending. That's why they call it bending moment or moment. إنزين فهذا هو المومنت. If you want to look at it like how it can be represented, it looks something like this. The equation ماله is the force that is being applied, in this case this F force, times the perpendicular distance. What does that mean? يعني احنا قاعدين نحاول نحصل المومنت about this point which is called O. Let's call this point O. فاحنا نبغى نحصل المومنت across around O يعني surrounding O لأن هني وين البندنج اللي قاعد يصير. يعني لو تشوفون هني this is where the bending will occur لأن this is where it is supported. إنزين ف we want to find the bending along O. How can we do that? We find the perpendicular distance اللي هو distance من هني لين الفورس, and it is 90 degrees with the force. That's what we mean by perpendicular distance. زين so this is the entire idea of moment. It is the force times the perpendicular distance. The unit will be, this is in newtons, this is in meters. For the moment, the unit of moment will be Newton meter. Then this is the whole major concept. It all depends on the perpendicular distance and the force that is being applied. We will go directly into solving questions from now, but just a few things before that لازم تعرفونه. إذا إحنا عندنا a force, زين دقيقة بس, let me go a bit more down. So if we have a force that is acting upon this in this direction, okay, perpendicularly downwards على هذا, هاي السبورت. لو تلاحظون the bending يعني if this bent, it will bend in this direction. يعني it is going into this direction. So this will be the direction of the bending, which is also known as clockwise. صح؟ لأن it is pushing it downwards. فit will take into the direction of clockwise. يعني كل ما force was applied harder and harder, it will keep turning in the clockwise direction. So this moment is in the clockwise direction, and clockwise usually is positive as a standard notation when it comes to forces and moments. All right. So the opposite would be something like this. إذا عندنا نفس الفكرة، عندنا طوفة هني، عندنا هالشلف. But let's say there was a force being applied to it from down. زين. If this was going to bend, it would bend into the opposite direction. لو تلاحظون, it is going in that direction, which is counterclockwise. فمعناته it is going this way. So when the moment is like this, it is negative or counterclockwise. Counterclockwise. تمام؟ فعادة clockwise they usually write it as CW and counterclockwise as CCW. So make sure you always know, depending on the direction of the force, depending on how the action is happening, where the bending might occur, and then that is going to be the direction that you have to follow. إذا كان clockwise بتحطون positive قدام الرقم، إذا كان counterclockwise بتحطون negative قدام الرقم. And that's it. All right? So the whole concept of moment, مثل ما قلت earlier, it's to just understand how much you need to counterbalance this force عشان ما يكون في حركة. الحين أنتوا لو تبون يكون عندكم شلف، إنزين, you don't want it to bend. أنتوا you want it to stay flat. So you want to provide a counter to it somewhere here, and there is a force being applied here so that ما يكون البندing قاعد يصير. There's enough support for it. That is the whole concept of moments, يعني the principle of moments. The easiest way I can explain how moment is most of the time used is in the case of when you have a crane. يوم يكون عندكم crane، لو تلاحظون نهاية الكرين هني يكون عادة في شيء متلصق فيه، يكون السبورت ماله أو الكاونتر ويت يسمونه. فهذا الكرين، زين، something like this. This is the crane, okay, and usually it will have like a load over here. بيكون عندكم load over here that is being carried by the crane. زين. فهني usually they would put something very heavy here called the counterweight. The idea of this counterweight is to counter the moment being caused by the load. لأن هذا اللود الحين it is causing a force downward، صح؟ فالكرين it will want to around this point، يعني this is the support point. إذا ما كان في له counterbalance, it will want to bend towards this direction. All right? And we don't want that لأن هذا it will be completely unsafe. يعني it will have a clockwise moment. زين. وهالclockwise moment معناته الكرين بيطيح، يعني بيطيح لقدام. And we do not want that. So instead, what we want is we want it to be balanced. We want the total moment around all of this, or we could say the sigma moment is equal to 0. The sigma moment about this point, let's call this the point C. About C, we want it to be equal to 0. Or in other cases, we call this equilibrium. And how is that done usually in cranes? يكون عندنا هني a counter weight اللي يكون وزنه وايد أثقل. Okay. عشان when we are carrying a heavy load, this will cause a moment in the opposite direction. So this is a counterclockwise moment or a negative moment, and this is a clockwise moment or a positive moment. عكستهم. This is a counterclockwise, and this is which will be negative, and that is clockwise, which is positive. All right. The idea is when you have a positive and a negative moment، يعني مثلا إذا هذا طلع لنا to be plus 50 وهذا طلع لنا minus 50. When you do 50 minus 50 plus 50 at the center ونجمعهم بيساوي 0. So it will be achieving equilibrium in our case. وما بيكون في وزن زيادة إن it's causing any bending. There will be no bending in the whole scenario. So you will be able to design a safe design. And طبعا this is just the concept behind moments and how moments are being used. The whole idea is you want to see the reaction of any object towards a given force and how much bending might occur and how we can avoid that bending. تمام? This is the whole concept of it. خلينا ندش في الأسئلة عشان I can explain the rest of the concepts as well. الحين هني السؤال يقول simply determine the moment about O. So it's very important to understand where the moment is being يعني where the moment you want to find it is about which point. يعني ممكن البوينت يكون هني، ممكن البوينت يكون هني، ممكن البوينت يكون قريب هني، بس على حسب السؤال وعادة it's usually looking at where the support is. In this case they're asking for at the point O. They're not looking at these points, we're looking at the point O. This is the point O. زين? This is a 50 Newton force. And it's given to be 16 centimeter distance. زين? So the first thing we check is the perpendicular distance to find the moment. We need to see from point O up to the 50 Newton force if it's a perpendicular distance. In this case, it directly is a perpendicular distance. So we already have the perpendicular distance, which is equal to 16 centimeters. And we have the force F, which is equal to 50 newtons. However, remember, you need to always have the units correct. In this case, this is centimeters. We need to find it in meters, which is going to be 0.16 meters. At this point, you guys should already know how to do conversions. And then, so you will convert it from 16 centimeters to 0.16 meters. We always want the units to be in meters and in newtons. تمام? And now we can solve. So the moment about O, the proper way of writing this is we will write the moment and then we will write a subscript of O, لأن معناته the moment around O is equal to 50 times, this is the force, F times perpendicular distance. All right, so 50 times 0.16, which is simply just equal to 8 Newton meters. All right. Now, one more thing. هني عادة they're not asking, but you need to know the direction of this moment. Since the force is going downwards, زين شو الطريقة you can find it؟ كأنكم حاطين هني هالpoint fixed, زين وانتو you're just applying a force. In which direction will it go? Okay? It will go into this direction. Alright? فهذا هو المومنت. فقاعد يروح كأنه قاعد يروح كذي in this direction. زين؟ This means it is a clockwise moment. So it is positive. So you can simply say this is plus 8 Newton meters أو توضحون إن this is 8 Newton meters clockwise. Okay, this is very important to know the direction. Why did you convert the distance into meters? لأن the standard unit for moment is Newton meter. زين؟ So you have to convert any centimeters. In this case, we have centimeter. We have to convert it into meters. That's the only idea because this is the standard notation. تمام؟ يعني it's not wrong if you write Newton centimeter, but this is not standard. It's not standardized. فكأنك تقول يوم واحد يسأل كم وزنك or whatever انت it's as if you're answering أنا 3400 جرام تقول له. فيقول له انا الحين بحسب لك انا الجرام لكيلوغرام وما ادري شو. You don't usually do that. We usually the standard version is in kilograms. So this is the exact same idea حق moments. We usually talk about Newton meters. تمام? So that's why we converted the centimeters into meters to stay in standard notation. All right, so this is basically it for the first question. The second question is given this force, and then I'm just going to redraw it. معطينا كذي bar, okay? This is point O. And then the distance from here to where to the end of the bar where the force is being applied is 3 meters. Well, force is at an angle. And it's 81 newtons. 81 newtons. All right? And they're giving you this angle to be, this angle is 15 degrees. Now, an important thing to know here is that احنا شنو قلنا؟ We need a perpendicular distance. صح ولا لا؟ We need to find the perpendicular distance عشان نحصل. We cannot just go directly take the 3 meters. لأن هاي مو بالperpendicular distance to the force. فكيف نطلع ال perpendicular distance? We can break this into two components. صح ولا لا? We can do one that is perpendicular and one that is along. So if I just redraw this over here again. Actually, let me just select this. Copy paste this here. زين. إذا بس أشيل ال distance هني عشان ما يكون في وايد خربطة. هني, so this is 15 degrees. فنعرف إنه we have two components. We have a component over here of the force. We will call this Fy لأن it's in the y direction. وبعدين بيكون عندنا another component over here of the force, which is Fx. You should be already familiar with this idea from the last class. فعشان نطلع الحين ال perpendicular distance, we have the perpendicular distance من Fy إلى 0. We know it's 3 meters. All the way from here to the O. I mean, not 0, to O. صح? But what about Fx? Do we have a perpendicular distance? لا. ليش؟ لأن it is acting exactly in the same line as O. يعني لو تلاحظون Fx is exactly on the same line as where O is. There is no distance between f of x and O. So the perpendicular distance in this case, perpendicular distance is equal to 0. So Fx, or the moment due to Fx, بيكون also 0. M of Fx بيساوي 0 at O. لازم أقول M at O. Because of Fx يساوي 0. Just because of Fx. ليش؟ لأن it's equal to force times perpendicular distance, و perpendicular distance is equal to 0. فما بنطالع إحنا ال Fx. إحنا بنطالع شنو ال Fy. ال force y. So that's the value we need to find. Now we know that this is 81 newtons. You can use trigonometry. Fy is going to be equal to 81 times cosine 15 degrees. You guys should already all be familiar with this, how to find the cosine of an angle and all of that. زين يعني هاي SOHCAHTOA. Basically if you draw the triangle بيطلع 81 cosine 15 degrees. So Fy is going to be equal to 81 cosine 15. Oops, my calculator is in radians. 1 second. Degrees. 81 cosine 15. It is going to be 78.24 newtons. And then, so Fy is 78.24 newtons, and this is the force we are looking at now. This is the component of the whole force that is causing a moment at O. ليش؟ لأن الحين لو if we go back to the original concept of the crane, إذا إحنا سوينا force على الكرين هني، إذا قاعدين ندز الكرين, we're pushing the crane from here, it is not going to cause any moments. ما بيسوي هذا bending فوق تحت. صح ولا لا؟ بالمنطق. لأن it is going to be just along the same line, so it cannot bend around it. يعني الحين لو انتم عندكم قلم في ايدكم, you have a pen or pencil, if you want to break it, you're gonna bend it. صح ولا لا? You're not gonna push it from the edge, from the يعني from the end of the pen or from the beginning of the pen, the point where you're writing with. لأن that will never bend it ولا بعد 100 سنة. You guys have to apply a force perpendicular to it, in a perpendicular direction, not parallel or along the same direction. This is the exact same idea why this force f of x does not affect any of the moment around O, but Fy, there is a moment caused due to it because there is a perpendicular distance. Now keep in mind, we only found our Fy. Now we need to find our moment. So moment at O is going to be equal to Fy times the perpendicular distance, which is 3 meters. So it's equal to 78.24 times 3 meters, which is equal to, this is in newtons, this is in meters, which is equal to 234.7 Newton meters. Okay, is that clear? One concept I want to clarify very quickly here, خصوص ال Fy Fx, just the trigonometry part of it. إذا عندكم force in this direction, زين, and you want to find its components like this, and like this, زين. Usually you would do the forced triangle and try to figure it all out and all of that. In the case when you want a quick shortcut to do such a thing بيكون معطينكم angle هني مثلا, okay? Let's call it 30 degrees. And then let's call this Fy and let's call this Fx. And this is our F force. All right? Fy, because the angle is adjacent, remember SOHCAHTOA toa. Then let's look at the sine and the cosine part. This angle is adjacent to Fy, so Fy is going to be equal to F cosine 30. و Fx, this angle is opposite to it, it's not adjacent to it. So سيدة تقدرون تكتبون Fx is equal to F sine 30. تمام؟ يعني these two ways you can just do it as a quick shortcut if you want بدال ما تروحون تسوون force triangle and all of that. If you have any force and you want to find its components, the angle which is closer to the F, زين يعني which is closer to the force that you're trying to find, this is going to be cosine. If it's further away from the force you're trying to find, in this case f of x, it is going to be sine and multiplied by the f force. And then this is just a shortcut, which is the derivation of, it's derived from the SOHCAHTOA method that you already know from the force triangle. Tamam? So because I'm going to be using this a lot now to save time while explaining the concept of moment. Now, let's go to the next one. Again, the same idea exactly. And then I'm just going to redraw this very quickly. So we have a beam again. This time we have a force in this direction. Okay? And we know that this angle, then let me do it dashed. This angle over here مع هذا is 30 degrees. Okay? And this is given to be 1 kilonewton. And we are given obviously the distance as well. It's 6.2 meters as a perpendicular distance. Then, now, again, we need to look at the perpendicular part of 1 kn, where the force is perpendicular and has a perpendicular distance. This is point O. Then, this is our fx, because it's in the x direction. Fx, and this is our fy. Okay? Fx has no perpendicular distance. The perpendicular distance is 0. ليش؟ لأن it is on the same line as O. It is on the exact same line as O. So there is no moment due to Fx, but Fy will have a moment, and the perpendicular distance is 6.2 meters. Now, if we want to find Fy using the shortcut, Fy is equal to F, which is 1 kilonewton or 1000 newtons. زين 1 kilonewton is equal to 1000 newtons. All right, so we'll change it to newtons from now. So we have the F force, F 1000. So this is F. Then times cosine or sine, we have to check. Is the angle in the same adjacent to the force we're looking at, which is Fy, or is it opposite? It's opposite. So we're just going to write directly sine 30 degrees. So Fy is going to be equal to 1000 sine 30, should be 500. Yes, it is 500 newtons. And now we found our Fi, but now we need to find the moment at about 0 due to Fy, which is Fy times the distance given, which is 6.2 meters. And in other words, it's 500 newtons times 6.2 meters, which is equal to 3100 Newton meter. All right, this is the whole concept when it comes to basic moments and basic beams and how to find the moment due to a force. Let's solve the next one. Now, here we have a little bit of trigonometry that we will need to do. So we are given a beam that is in this direction, it is slanted, okay? This is point O over here. And they are saying that this is making 30 degrees with the ground. The distance from here up to the top زين is 40 meters. And we have a force that is being applied here that is vertical. A vertical force that is being applied here, which is 0.5 kilo newtons. زين? So it's saying 0.5 kilo newtons. I'm just going to change it from now to 500 newtons. All right? لأن 1 kilo newton is equal to 1000. فنص كيلو نيوتن بيساوي 500 newtons. Okay? زين? Now, there are two ways you can solve this. First, you can either find the perpendicular distance from O, يعني this distance from here to here. This is the perpendicular distance ترى. This is also the perpendicular distance on where the force is being applied. You can either do that and find how much this green distance is and use that as your perpendicular distance. Nothing wrong with that. Or you can change the forces, find the components of these forces by doing it. One that is going to be perpendicular over here. عشان this we have the perpendicular distance. And then one which is going to be, just 1 second, let me move this a bit higher up. And then one that is going to be in this direction, which is parallel with it, which will have no moment due to it. So these are two different ways you could do it. You can either find this as your perpendicular distance, or you can find the component that is causing the perpendicular that has a perpendicular distance with where it is. Both will give you the exact same answer. Tamam? Now we need to do some trigonometry. We know that this is a right angle. And then, because this is a right angle, we also know that this is a right angle. We know that this is a straight line. يعني هني, the red part is a straight line. صح ولا لا? This is a fully straight line from here to here. We know that this is 30, that معناته this is 60 because this is a triangle. زين. If this is 90, this has to be 90 minus 60, which is 30. Why? Because the عندنا زين, we have this, a straight line. We have this force coming here, and it is making a 90-degree here. For how the 90 degrees, we know that this total thing is 180, that's straight line. We know that this is 60, rules of a triangle. 30 plus 60 plus 90 has to be equal to 180. And then, now we have this part that we need to find. So it's going to be 180 minus 60 minus 90, which is equal to simply 30. Tamam? That's simply it. So this is 30 degrees. All right. Now we can find the moment. Simply, we found our perpendicular force. We can find our perpendicular component, our force component Fy. Fy is going to be equal to, is the 30 degrees adjacent to it, or is it opposite? It's adjacent, so it's going to be cosine. So it's going to be 500 newtons cosine 30 degrees. So Fy is going to be equal to 500 cosine 30, which is 433 newtons تقريبا. All right, that's how you'll find it. And now you can just find the moment about O. So moment at O is equal to, the perpendicular distance is what? 40 meters. Let's do it force first. The force is Fy times the perpendicular distance, which is 40 meters. So it's equal to 433 times 40 meters, which is equal to 17,320 Newton meter. Or you can write this as 17.32 kilo Newton meter. These are both acceptable answers. These are both correct answers. You can either write it as Newton meter, or you can write, divide by 1000 and write it in kilo form. Both are correct. Tamam? Let's do a few more. Let's finish all of these actually, because it's the same concept, but it will have different directions. Again, this is very similar to the previous question. The only difference is the force now is not upwards. It's not vertical, it's horizontal. So let me just redraw it real quickly. عندكم إياها كذي. And it's making 30 degrees over here. The force now is horizontal, which is 0.5 kilonewtons, which is simply 500 newtons. And then the distance from here to here is 40 meters. And this is point O, where we need to find the moment about. Same idea again. So we will change this into its components. So there's going to be a component this way, which is parallel. And then there's going to be a component this way, which is perpendicular. And then, again, this is the component that will have effect. Fx has no effect because it's parallel. Then, and now we need to figure out the angles. Again, it's very straightforward. This is going to be 30 degrees. So corresponding angle over here will be 30 degrees. Right? Same exact concept as before. Not يعني, because if you notice, this is making an angle here with the same line with the vertical. So this is going to make the same angle, I mean with the horizontal. So this will make the same angle with the horizontal. يعني هذا اللاين هني لو تشوفونه لاين سيده صح؟ لاين سيده. فهني اذا عندكم ارضيه بيكون 30 degrees يعني، وبعد هني اذا كان عندكم ارضيه او يعني horizontal line بعد بيكون 30 degrees. تمام؟ we instantly found the angle here. Now we just need to find the force component that is perpendicular اللي هو Fy, which is equal to 500. Is it opposite or is it adjacent? It's opposite. So in this case, it will be sine 30. So Fy is equal to 250 newtons. Now we need to find the moment M. M is at around 0 is going to be equal to the force Fy times the perpendicular distance to Fy, which is 40 meters. Then this distance from here up to here is 40, and it is perpendicular with Fy. Okay. 250 times 40, which is going to be equal to 10,000 Newton meters. Or you can write this as 10.0 kilo Newton meter if I divide by 1000. One thing I didn't comment on all of these questions is the direction. زين خلينا we look at that very quickly now for each one. هني the direction of this is going downwards. زين the direction is going downwards. فبيروح the direction into this way. So this is clockwise. All right. So we're going to have to say that this moment is clockwise. All right. هني in this case, again, it is going downwards. So again, this will cause it to go clockwise. زين يعني if it would bend clockwise. So here the answer is going to be clockwise. In this case, the force is going upwards, the green force, the one that is causing the moment قاعد يروح فوق في هذا الاتجاه. فيعني لو بيسوي bending بيسويها الصوب. So this is counterclockwise. زين exactly, anti-clockwise or counterclockwise. So this moment here is going to be counterclockwise. تمام? This force here is causing it to go into this direction. So this is clockwise. That's the whole idea. يعني everything, it depends on where the force is. إذا يعني فكروا فيها بالمنطق. Think of this as a كأنها مسطرتكم. المسطرة اللي عندكم إياها لو مسطرة بلاستيك. إنزين. If you have a plastic ruler and you are putting a force on it on the edge, which way is it bending? You will see that it is going downwards. يعني the shape of it is going into this direction. So this is going to be a clockwise bend. So here, this moment is going to be clockwise. So the clockwise is positive, this moment is positive, this moment is negative because it's counterclockwise. وهلا مجرى. All right. You will see in the next questions, the second worksheet when we're going to do it, that how direction will play an important role. Now, هني they're trying to just do a trick, a little small trick. معطينا a beam, all right? ولكن they gave us a force that is being applied here and vertically downwards. And they gave us the distance from O, here to the force, to this force over here, to be 60 millimeters. Then, first thing I would do is change this perpendicular distance from 60 millimeters to 60 times 10 to the minus 3 meters, or it is equal to 0.06 meters, I believe. Yes, all right. So first thing I'll do is change this perpendicular distance into meters, and then so I can remove this and write from the very beginning that this is 0.06 meters. And the force given is 200 newtons. And the angle we have here is 30 degrees. Again, we will solve the exact same way. If we are going to connect this triangle, this is a right angle triangle, triangle. فإذا هذا 30 هذا بيكون 60. And then this angle is going to be 60. Oops. This angle is going to be 60. Before that, let me just draw the components. So we're going to need a perpendicular component. And we're going to need a vertical, a parallel component, I should say. So let's call this fx and let's call this fy. And this is our 60 degrees right over here. And then, obviously, fx has no effect on the moment because it's, again, parallel with the direction of where the moment is. Fy is exactly perpendicular with the moment itself. It's causing a right angle. So fy is going to be equal to 200. How do we know if it's sine or cosine? We look at the angle. It's 60 degrees, and it is opposite, so it's going to be sine of 60 degrees because it's not stuck to the direction of this force. يعني it's not بالضبط متلصق فيه. It's not adjacent to it. So it's going to be sine. And then Fy is going to be equal to 200 sine 60, which is 173 تقريبا يعني newtons. And now we can find the moment. M is equal to the Fy times the perpendicular distance, which is 0.06 meters. So it's equal to 173 times 0.06. So M is going to be equal to 10.39 Newton meter. What is the direction of M? We go back here, look at where the force is going. The force is applying a moment in this way. زين? يعني كأنه you're fixing point O and then you are bending it from here. So it's going into this direction. So it's a clockwise moment. So it's positive or a clockwise moment. And this is the basics of moments. تمام? Is it clear for you too? Okay. I will go now into the more difficult questions of moments. They're not difficult, but they are more realistic. And how sine, explain it again? No worries. فالساين هني, if I'm going to show you this again, بس برد أرسم هاي بس مكبر تحت. So we have the force, the actual force this way, vertically down. We have the perpendicular Fy. And we have the one that is going across. Then the force over here. So we have these three forces, which is the same here, بس مكبرنا, and we know that this is 60 degrees. تمام? We know that this is 60 degrees. So using SO ka TOA before, what would we do? We would rearrange this triangle so that we will complete the triangle and then do the analysis of it ونطلع الانجل ونستخدم SOCA وتوا. ولكن a shortcut method is if this is fx and this is fy and this is f. So if it is adjacent, in this case f of x, the angle is adjacent to it يعني متلصق في fx نفسه. So fx is going to be equal to the force f times cosine, and it's adjacent, so we're going to be using cosine of 60 degrees. In the case of Fy, the angle is not adjacent to Fy, it is opposite to Fy. So we're going to say it's equal to the force F again, the same force, sine 60 degrees. This is simply just a shortcut of the SOHCAHTOA method that we usually do. All right? Lana, if you remember from forces, from arranging forces, احنا what do we do usually? A resultant force لازم يكون الاديشن مال fx و fy, and it has to be arranged in this way. So this will be fx and this will be fy, زين, and this will be our force F. تمام? This is F, Fx, Fy. This concept was clearly explained in the previous session, so refer to it if you're a bit confused. But this is how it would look like. This is our angle 60 degrees. زين. For now, we know that this is a right angle over here. تمام? So معناته, what can we do? We can we know that F is the hypotenuse. This is H. This is adjacent A, and this is opposite O. And then we can just apply SOHCAHTOA. It's the same exact idea. So يعني if we're looking at the sine part, so the sine part would be sine 60 degrees is equal to opposite over hypotenuse, زين, which is equal to Fy over F. بعدين if we rearrange this, we can take the F to the other side, يعني we will just multiply this over here. Sine 60 will be, يعني F sine 60 will be equal to Fy, which is the same thing we managed to find out here directly with the shortcut. That is the whole idea. يعني we're just doing a quicker simplified version of this by just looking at the location of the angle when it comes to finding the components of a force. Same thing will obviously be applied to cosine. All right. Inzin. We have a few more questions here as well I want to go through. But let's just take a 5 to 6 minute break, Inzin. And we will continue inshallah. At 11 exactly, we'll be back to continue. Tamam? Any questions before we take this break, Ali? Anything not clear from what I have explained? تبغاني شيء أشرحها أرد واضحة؟ Okay, تمام. Fatima, what about you? If you are still with us. All right, perfect. ممتاز. خلاص بناخذ break شي 5 دقائق. At 11 exactly, inshallah, we'll be back and we will continue the rest of the worksheet. Oh, as you can see, it's very, very straightforward and easy. All right, let us continue with the remaining questions. Let's see. هني it says we have a force of magnitude 60 newtons which is applied to the gear in this way over here. Determine the moment of F about a point O. When you have any figure given to you, diagram given to you, always first draw the free body diagram بروحكم من صوبكم, so that it is much easier to analyze, much easier to solve and understand from your side. All right? Now, to draw it, we are going to look at what is given. We are given the point O in the middle here, and then a distance over here is given. And we have the force being applied in this way. And we know that the force is at 20 degrees. And the force is 60 newtons. Right? And we are given the radius in this diagram. We are given the radius of the gear is equal to 100 millimeters over here. So this is a radius. So this is also the radius. The radius of a circle is the same everywhere around. So هني بعد, this distance from here to here is also the radius r. Okay, so this distance is the distance r, which is equal to 100 millimeters. تمام؟ لأن it is a gear. All right, فit's circular, the radius is going to be equal. So it is equal to 100 millimeters. We will change it from now. R is equal to 100 millimeters. The usual way of how to change it is you would divide by 1,000, or the way I usually do it is this. If it's too confusing, I put meters up, the dimension I want, and millimeters down. 1 meter has 1,000 millimeters in it. فالمليمتر والمليمتر بيتكنسل. So the radius in meters is going to be equal to 100 over 1,000 meters, which is equal to 0.1 meters. زين? So it's not 1 meter, it's 0.1 meters. All right, so we have the distance, and now we can do the same thing we always do. We break this into components. So we're going to have a component this way. We're going to have a component this way. زين? And we're going to have a component that is going like this. Fx does not matter. We're not going to look at it because it's on the same line as O. This is O. And we have Fy, which is perpendicular. So we need to find Fy. Again, this is 20 degrees. It is adjacent. So Fy is equal to 60 newtons times cosine. Then that's adjacent of 20 degrees. So Fy is going to be equal to 60 cosine 20, which is 56.38 newtons. Tamam? Now that we have that, we can simply find the moment about O is going to be equal to Fy, which is 56.38 times the perpendicular distance, which is 0.1. So the moment is going to be 5.64 Newton meter. What is the direction of this moment? The force is being applied downwards, so the moment is going to be going into this direction. So this is clockwise. So it is 5.64 newtons clockwise. All right. Simply, that's how you can find it. It's a very easy question, and it's very direct. Tamam. Let's go to the next one. Again, this one is very straightforward as well. It says calculate the moment on the handle of this monkey wrench if the force is 250 newtons. And then, now, here, it is a little bit more different. Before, we usually did not have a, let's draw the free body diagram so you can see how it is going to be different. So this is the point that we want to know. We want to know about the center of the bolt. Where's the center of the bolt? This is the center of the bolt over here. Insane? So this is our point O. Let's call it that. So this is point O. If I want to redraw this, insane, we have a distance like this, and then we have a distance over here like that. Insane. Now, this is point O. We know that this distance is 30 millimeter, which is 0.03 meters, 200 millimeters, which is 0.2 meters. All right, I just did the conversion instantly. And we have a force that is being applied here. Okay, this is 250 newtons. And we have an angle of 15 degrees. Now, keep in mind here, we're going to have, again, let's break it into components. We have an fx, an fy in this case here, and an fx. Okay? Now here, notice that this fx is not parallel with the point O. It is not exactly at the point O. We have an actual perpendicular distance. يعني إذا إحنا طولنا البوينت O هذا زين, you will notice there is a perpendicular distance that is being applied due to f of x. ونفس الوقت, there is a perpendicular distance because of f of y, which is going to here. This distance here, which is 0.2. So there is a distance. So f of x is acting and f of y is acting, causing يعني a moment about O, because none of them is going directly through O. So now we're going to have to find two moments. We're going to have to find the moment due to f of y and the one due to f of x. So first, let's find f of y. F of y, the force f of y, is equal to F, which is 250 newtons. 15 is adjacent, so it's cosine 15 degrees, which is equal to 250 cosine 15 is 241.48 newtons. And now f of x, we need to find it because it is causing a moment. It's going to be 250. The angle is opposite, so it's going to be sine of 15 degrees. So f of x is equal to sine 64.70 newtons. And then this is the first thing we did. We found our f of x and f of y. Now we need to find the perpendicular distance for each. So the perpendicular distance in the case of f of x is this distance over here. This is the distance of f of x, which is equal to 0.03 meters. So the perpendicular distance هني is equal to 0.03 meters. And for f of y, this is the perpendicular distance from here to here. This is the perpendicular distance, which is 0.2 meters. And now we can find the moment for each. So the moment of y about O, all right, from y, this is equal to f of y times 0.2, which is 241.48 newtons, which is equal to times 0.2 meters, which is equal to 241.48 times 0.2. That is going to be 48.3 Newton meter. And then we'll do the same thing for the x part. So the x moment about 0 is going to be equal to f of x times 0.03 meters, which is equal to 64.70 times 0.03, which is going to be 64.70 times 0.03, 1.9 Newton meter. تمام? Now the important part here is the direction. Then this is okay. We found the moment due to y and the moment due to x, but now we want to find the total moment. So for x, where is the direction of the force? It is going into here. It is going into this direction. صح? So it's causing a moment of this direction, which is counterclockwise. So we know that this is a counterclockwise moment. So this is going to be equal to minus 1.9 Newton meter. And then we know that this is negative. In this case, in the green part, we're going to look at Fy. Fy is going to this direction, so it's causing a moment. It's going to this direction, so it's causing a moment like that, على البيم. So this is a clockwise moment. So this is going to be clockwise, or in other words, 48 plus 48.3 Newton meters. It's positive. So the total moment, we're just going to find the sum. The total moment about 0 is going to be 48.3, or I could just simply write it as y m0, then the moment of y m0 plus the moment of x m0. And then if we substitute here, this is going to be plus 48.3 Newton meters plus minus 1.9 Newton meter. We're just summing them up, we're adding it, we're finding the total moment. The way you do that is you just add it all together. And then this is negative, so this is going to become 48.3 minus 1.9, which is equal to 46.4 Newton meters. Since the final value came out as positive, positive means the direction is clockwise. All right, this is how you know how the final direction is. If it's positive, it will be clockwise. If it's negative, then it is counterclockwise. This is how you are using the directions. Again, we are looking at the directions. When we're looking at f of x, it is causing a force in there. فإذا هذا بيتحرك بهالاتجاه بيدور كذي يعني counterclockwise. So it's negative. من f of y بيدور بهالاتجاه. So it's clockwise. Therefore, clockwise, this will be positive and this will be negative. And then you will just sum them up. When you're adding them up, this is a negative value. So it's going to be 48.3 minus 1.9. تمام. We're going to do more questions. It's going to be the same concept. بتشوفون how the negative and positive is. Just make sure you understand how you're finding the directions. Yani make sure here you know that f of x is causing a counterclockwise moment. Know that this f of y is causing a clockwise moment. أسهل طريقة حطوا نفس إيدكم هني أو حطوا قلم من هني لهني. إنزين. يعني you could simply just put a line from here to where the force is. All right. Okay. And now if you select this force, هذا حق ال f of y. If you select this force, if we applied the force downwards, شوفوا الاتجاه, how is it going to rotate? It is going in the clockwise direction. صح ولا لا? Again, so if this is the force for the green one, يعني this is the force of f of y, okay? Put a point from 0 to f of y. You are going to be rotating it clockwise. All right? Then now look at it in the case of x. Look at it in the case of x when it's blue. Then the force x is pushing it that way. فانتوا بتحركونه هالصوب. شوفوا it's going in the opposite direction. لأن هني f of x is being pushed in that direction. If you're looking at this point at the tip, then x is going in that direction. فانتوا بتحركون الروtation in that direction. So how is it going? It's going counterclockwise. And that's how you are able to tell the difference. تمام? I hope that made it a bit more clear. طبعا with more practice you will get it more and more. Let's do more questions so the concept is getting better. Insane. Now, this one is a bit different, the way to solve it. Here, you are given a force of 200 newtons that is applied to the end of a wrench, عندكم wrench, insane. To tighten the flange bolt, which holds the wheel to the axle, determine the moment M produced by this force about the center O. Now, يعني لو أكبر لكم الصورة شوي. زين. لو تشوفون البوينت O is in the middle هني. This is where point O is. But the torque wrench is being used at this point. It's not being applied at O. So here we want to find the torque at O. We don't want to find the torque at this point. So we need to change up a bit the direction. لأن the perpendicular distance is a bit different. Now we know that this force is a perpendicular force being applied. So we know that much. And then, but we need to figure out the distances, the new distances based on المعطيات يعني what we are required to find. Let us draw the free body diagram of this. زين if I draw it on this very quickly عليه بيكون عندنا هذا التورك wrench. زين and then there's a force being applied here. We know this angle over here. All right. ولكن we need to not find this perpendicular distance. If I extend this force, زين if this is just a line to extend the force, احنا we want to find this line over here. This is our actual perpendicular distance. تمام? The purple part is the actual perpendicular distance. If I just select this and copy paste it here, this is what it will look like. All right. So this is our force being applied up here, the right angle force. زين. We need to find this. Let's name the points. Let's name this. This is point O in purple. And let's name the intersection between the purple and the red here as D. Okay. And the triangle, let's call it triangle A, B, C. زين. These points over here. what distances معطينا؟ معطينا ان هذا من هني لين هني is 450 millimeter. This is 450 millimeter. All right. معطينا this distance is 125 اللي هو this distance from this point to this point. All right. يعني the distance from one bolt to the next bolt is 125 and O is in the middle. For the distance AO زين is going to be equal to the distance AO اللي هو هذا distance AO. This is going to be equal to 125 divided by 2 لأن لو تلاحظون the total distance is 125 from one bolt to the other. فمن البولت لين النص بيكون نص شو اسمه القيمة نص 125. So it's equal to 62.5 millimeters. So we have this distance over here. زين AO to be 62.5 millimeters. Now the whole aim of what we are trying to do is we are trying to find the distance OD because this is the actual perpendicular distance from point O to the force that we are trying to find. They want it at the center of the wheel, not at where the torque wrench is being used. And we are also given one last thing. We are given that this angle is 20 degrees. This angle over here is 20 degrees. فمعناته also this angle over here is going to be 20 degrees. لأن they're the same line بس اللهم متحرك على يمين شوي. The angle is not changing. All right. We know the angles. We know that this is a right triangle. We know that this is perpendicular and this is perpendicular. So if we look at just the outside triangle, all right, let's look at just the outside triangle. The outside triangle looks like this. زين ال ABC يعني triangle ABC is like this. This is A, B, and C. This is a right angle. عندنا this 450 وعندنا AC عندنا this angle is 20 degrees. So we can apply SOHCAHTOA here to find the AC. ال AC, what is it? It is the hypotenuse. صح ولا لا? This is H, hypotenuse. زين. So we can use SOHCAHTOA to find this. How will we do that? We have this angle, 20 degrees. We are given the adjacent angle. So we're going to use cosine of 20 degrees is equal to adjacent, which is 450, over the hypotenuse, which is AC. معناته AC is equal to 450 divided by cosine 20. Then just rearranging the equation, which is going to be 450 divided by cosine 20. 478.88 distance. It's just a distance, so it's millimeters. And then 478 millimeters. Okay, now we found this full distance AC, and we have this distance AO. All right. So now we're going to look at the smaller triangle. This is the smaller triangle, which is ODC. And then this triangle ODC. And then again, this is 20 degrees. احنا remember we are trying to find this side, OD part. تمام؟ الحين what do we need? We need one more side to find. We need to find one more side to be able to find this. Which side can we find? We can find the OC part. لأن عندنا AC وعندنا AO. If you remember in lines, إذا عندنا straight line, زين, if I just draw the bottom line الحين, هذا الline AC. Okay? This is the line AC. And this is point O over here. This is point O. Okay? Don't get confused. This is just the line, the bottom line, اللي هو AC. We know that AO, طلعناه من قبل. We know that AO is equal to كم? 62.5. This is 62.5 millimeter. زين? And we know that all of AC, so we know that all of AC, كامل AC, طلعناه فوق هني. AC is 478.88 millimeter. So now we can simply find the remaining OC. اللي هو هذا. The green part that is remaining. So it's simply going to be equal to 478, the total line, 478.88 minus 62.5 millimeters. يعني هو OC لو بس احنا نشيل هالبارت. If we remove this part from the total distance AC, which is 4788, بيبقى لنا ال OC. So OC is equal to this, which is minus 62.5, 416.38 millimeter. So this is the distance OC, 416.38 millimeter. Now again, we have a right triangle. We're trying to find the perpendicular distance اللي هو OD. That was the whole idea from the beginning. Since OD is perpendicular distance, 416, this is the hypotenuse in this, زين, and this is the adjacent. So again, we will do SOHCAHTOA, so cosine 20 degrees is equal to adjacent. This is the adjacent part, which is OD, over the hypotenuse, which is 416.38. So OD is going to be equal to 416.38 times cosine 20. OD is equal to 416.38 times cosine 20 is equal to 391.27 millimeter. All right. This is what I got for OD. So now we know that this distance is 391.27 millimeter. This is our perpendicular distance اللي نبغى نطلعه من البداية. All right. This OD, which is the perpendicular distance from the force to point O. And now we can simply just find the moment. Moment about O is equal to the force. What is the force given? To be 200 newtons times the perpendicular distance, which is 391.27. But this is in millimeters. So we need to change that first before I write it to meters. This is going to be equal to 0.391 meters. 0.391 meters. So the moment about O is going to be equal to 200 times 0.391 meters, which is 78.25 Newton meter. تمام? Last thing we need to do is know the direction of it. So this is the direction. The force is going this way, and then so it's going to cause a clockwise moment on it. So the direction is clockwise. Tamam, as you can see, mostly here it is all about the شو يسمونه it's more about the trigonometry. It's more about finding يعني ممكن السؤال يكون about the forces where you have to analyze. Sometimes it can be about the geometry of finding the perpendicular distance, and sometimes it can be both combined. All right. فهني clockwise معناتها this is a positive moment. All right. Very straightforward. Is this clear? يعني does it make sense what I did here? This could be, I think, for me, I think this might be one of the toughest questions they could ask. لأن there's a lot of trigonometry, and I know people usually have a tough time when they're trying to do trigonometry. But this is the whole concept. This is the whole idea of how to do it. And then let's go to solving the next question. And then calculate the moment of the 90 Newton force, الفورس هني 90 Newton, about point O. This is point O over here. And then this is our point O. For the condition when theta is equal to 15 degrees. So they gave you a theta angle here, which is 15 degrees. And then it says also determine the value of theta, which the moment about O is 0 and maximum. Let's go step by step. First things first, draw the free body diagram. And then a point O. زين. And then a line هني, and this is where the force is being applied. This line is 800 millimeters or 0.8 meters. This is 600, which is 0.6 meters. And this is the force. And for part A, we know that this is 15 degrees. Right? The force is 90 newtons. We just break it into components directly. Then we have the Fy, sorry, and then Fx direction. طبعا direction arrows will be depending on the arrow of the Newton, of the original force. فإذا arrow هني, these arrows have to match where the arrow of this force is. تمام? And this is Fx. We can find Fy and Fx directly. Fy is equal to F cosine, because it's adjacent, 15 degrees, which is 90 newtons. 90 cosine 15, which is equal to 90 cosine 15 is 86.93 newtons, and Fx is going to be equal to F sine 15, and it's opposite, which is 90 sine 15, which is equal to 23.29 newtons. All right. We found out our Fx, our Fi. Now we need to know the perpendicular distance for each. فالFy, the perpendicular distance ماله is this distance from O up to here, the perpendicular distance, which is equal to 0.6 meters, as you can see at the bottom. فالM is going to be equal to M of O due to Y is going to be equal to 86.93 times, which is Fy, times 0.6 meters, which is equal to 0.6 times 86.93, 52.158 Newton meters. No need for all of this. Let's just write 52.2 Newton meters. هني we will look at the direction as well. The direction of Fy is upwards, لا? It is causing it to go like this around O. Then we're looking at O, it's causing it to go like this around O, which is counterclockwise. So counterclockwise معناتها negative. So this is going to be equal to minus 52.2 Newton meters. Same thing we will do for X now. M moment around O due to X is going to be equal to 23.29 times 0.6 8 meters, which is the perpendicular distance. How? لأن if we extend this distance over here is the perpendicular distance with f of x, which is 0.8. So we find out that the moment due to x is going to be 0.8 times 23.29, 18.6 Newton meter. Let's look at directions. So the direction of f of x is going that way. It's going this way. So it will cause, if we're going towards O, this is how it will look like. And then, so it is a clockwise moment. So it's positive. So this is a clockwise moment. معناته it is plus 18.6 Newton meter. Now we're just going to add them up. So minus 52.2 plus 18.6, which is going to be, so the total moment, sigma moment about O is equal to this, which is going to be equal to minus 52.2 plus 18.6 is minus 33.6 Newton meter. What does the minus indicate? The minus indicates that this is a counterclockwise moment. That's what the minus indicates. So this is a counterclockwise moment. The direction is counterclockwise. Tamam? Or anti-clockwise, whichever you want to write, both are correct. Then, so this is, we've already done this earlier, same exact way of doing it. Find our Fy, our Fx, find the perpendicular direction, distance for each one. بعد ما تطلعون perpendicular distance تضربونهم في بعض وتشوفون إذا clockwise ولا counter clockwise من الدايجرام مالكم. وبعدين شو اسمه, you will add them up so that you can find the total moment that's happening around O. So this is just part A. الحين for part B. I'll also determine the value of theta for it. Okay. شكله عندك سؤال. I'm just waiting for you. علي, عندك سؤال شيء قبل ما أكمل؟ About how you can find whether it's clockwise or counterclockwise. إنزين. There is a different way you can do it. إنزين. This part. I copy paste it. بسهل لك الموضوع كامل الحين إن شاء الله. إنزين. اوكي, عندنا ال fx عندنا ال fy صح؟ fx هني و fy هني. draw a straight line من fy. تشوف وين السهم؟ كمل خط سيده. اوكي, بتسوي خط سيده. let me do it in a different color. فبتكمل خط سيده لين ما توصل صوب البوينت O. عشان I reach point O, do I go left or do I go right? I have to go left. فأنت بتلف عشان تروح صوب O. Which direction is this? Counter clockwise. Yes, that's the same thing you will do for the x value. بتسوي خط سيده من السهم. خط سيده. وصلنا لل O. بنروح يمين ولا يسار؟ بنروح لفوق. بنروح, we'll go towards O like that. So this is clockwise direction. Is it clear now? This is how you can always find out whether it's clockwise or counterclockwise. تمام? So let's just keep this on the side over here. زين. Now part B is asking when the moment about O is equal to 0. شو معناته؟ معناته هني this total moment لازم الجواب يطلع لنا 0. وين هني سوينا minus 52.2 plus 18.6. The final answer should give us 0. So how do we do that? تتذكرون قبل how did we manage to get O to be 0? لو تروحون شوي فوق نرجع للأسئلة القبلية اللي هني. How did we get the moment here 0? Due to f of x. متى كان 0? When f of x was along the line of O. يعني هني f of x had no moment. ليش؟ لأن it had no perpendicular distance. معناته ال perpendicular distance ماله لازم نخليه يصير 0. How can we do that? So if we look at this drawing again, or let me just redraw it هني ال free body diagram. فإذا عندنا اوكي وعندنا الفورس هني قبل ما ارسم الفورس هني عندنا ال O. Alright? What do we need to do again to get 0? We need to get the perpendicular distance has to be equal to 0 to get a moment of 0. صح ولا لا؟ The force has to have a perpendicular distance of 0. So how is that going to happen? When the force is in the direction of ال point O بالضبط لأن هني ما بيكون عندنا perpendicular distance at all. So this is the angle theta that they want us to find. It's with here. This is angle theta. And we are pointing now our force, our 90 Newton force, in the direction of O. And we know that this is 0.8, the distance, meters, and this is 0.6 in meters. Now, if you notice, we have a triangle. We have a right triangle where this is a right angle. We have a right triangle. So if I just redraw the triangle, it's going to look something like this. And then this is a right angle. This is also a total right angle, صح? So we know that this is going to be theta, and this is going to be theta. Alternate interior angle, صح ولا لا? Vertical line, the line between them. So this is going to be theta since this is theta. Or you can say that this is 90 minus theta, لأن this is a right angle. So this is 90 minus 90 theta اللي هو theta. Both can work. زين? But this is theta. If you know your rules from trigonometry, from basic angle theory, this is also going to be theta. We have 0.8 and we have 0.6. So we need to find an angle theta. We have an adjacent. This is the adjacent part. And this is the opposite part. So we're going to use TOA. زين فtan theta is equal to adjacent opposite over adjacent اللي هم شو opposite 0.6 شو adjacent 0.8 زين which is equal to 6 over 8 which is 3 over 4 I think yes 3 over 4 يعني 0.75 زين فثيتا is going to be equal to tan inverse of 0.75 زين so theta is going to be equal to tan inverse is just shift tan in the calculator 0.75 which is 36.87 degrees. Very straightforward. Again, this very quick recap. Whenever they're asking for a zero moment, معناته the force has to go directly through the moment. The direction of the force has to go directly through it. In other words, ما يكون فيه perpendicular distance. تمام? For part C, they're asking for the maximum moment. زين? The maximum moment is very simple. It is when the entire force is exactly perpendicular to O. زين؟ يعني this is point O. If I redraw this again, it's something like this. احنا نبغى الحين الفورس يكون بهذا الاتجاه. Alright? بهذا الاتجاه. ليش؟ لأنه we want this distance over here to be perpendicular. نبغى the full force to be perpendicular to this thing. يا يكون كذي يا يكون حتى الفورس in the other direction. It doesn't matter. لأن they didn't say they wanted a specific clockwise or counterclockwise moment. They just said they wanted the maximum possible moment. إنزين؟ For all you're gonna have to do is يعني قبل what did we say? we wanted the force, the older force, إنزين هني من 0. How was it? The angle was a specific angle that gave us a force 90 degrees from this. So all you have to do is just do theta plus 90 degrees. Theta at 0 plus 90 degrees يعني 36.87 plus 90 degrees. وبس. That's it. So the whole idea is you want the force to be at a right angle with the moment you are trying to find. المومنت 0 هني. Alright? فيعني هذا الفورس هني. This is F when moment is 0. Alright? هذا I'll change the color of it عشان بس ما يكون في خربطة. هذا it is, and let's do it as or purple. زين. هذا بعد purple. These are when the force is when moment is equal to the maximum perpendicular to the force. زين. لأن معناته شنو when it's perpendicular؟ الديستنس معناته is at the furthest perpendicular distance. فالديستنس بيكون أعلى distance معناته الفورس will be, the moment will be the highest moment. This is the furthest possible distance. If you remember back from the last session, you can always achieve the maximum distance and then when the moment when the distance, when the line is perpendicular. And I did a good explanation about it in the last video if you want to look at that. فلا تنسون moment is at the end of the day force times distance. صح ولا لا؟ If the force ما نقدر نغير في الفورس شيء, it's constant, بس نقدر we increase the distance to the maximum possible distance, which is the perpendicular distance. فهني بيكون ال perpendicular distance عشان يكون ال maximum force ماله يعني 90 degrees عشان يكون perpendicular عشان يكون maximum force أكثر شيء. And when is it perpendicular? When it's 90 plus, لأن this is 90 degrees, فit's plus 90 من the moment when it's at 0. You can directly just find it this way. تمام? And this is how you would solve such a question. Now let us go to question 5. زين. The masthead fitting supports the two forces shown. Determine the magnitude of T. فإحنا we need to look at T, which will cause no bending. Important. It says no bending of the mast. معناته شنو؟ يقول لكم zero moment at point O. معناته sigma MO has to be equal to 0. يعني equilibrium. يعني ما قاعد يستوي bending. Okay? So how do we do this? First things first, let us draw our free body diagram, always. زين? Let me just drag this to the bottom so we can draw it the same way. But let's start from the left to the right. أول شيء, where's point O? Point O is in the middle somewhere هنا. زين? بعدين عندنا ال C هني, point C. Alright? بعدين عندنا a distance from C to this. This is where the force is being applied, the tension force of 5 kilonewtons. زين? Of 5 kilonewtons. And then we have another distance in the other way. And we have the tension T. And then we have our tension T that is being applied here. The force due to tension يعني هني. All right? فعندنا two forces. عندنا on the left 5 kilonewtons, on the right T, which we need to find. Now if we look at the dimensions, معطينا ان this is 90 millimeters. زين لين هني. معطينا هذا 120 millimeters. This is point C, this is point O. نعرف ان the distance from C to O is 60 millimeters. Right, this is 60 millimeters. تمام? So we have all these dimensions. We also know that this angle over here is 30 degrees. وهني رسموا لنا مثلث in ratios of 2 and 5. Let's let's deal with these ratios. Okay, now we don't need this picture anymore. We have our free body diagram. We can work on that. So let's get rid of these ratios and find the angle to simplify everything. Ratios معناته شنو؟ إذا عندنا هني 2 and 5. This is 5, this is 2. معناته we are trying to find this angle هني. Let's call it theta. All right. This is the right angle هني. This is the hypotenuse. معناته this is tan inverse of, or let's do it step by step. زين. So كتوا عندنا احنا adjacent وعندنا opposite. ف we will just do tan theta is equal to opposite, which is 5, over hypotenuse over adjacent, which is 2. Yep, زين. And theta is equal to tan inverse of 5 over 2, which is equal to 5 divided by 2. The tan inverse of it is 68.2 degrees. تمام. Where is this angle? It is here. الحين بنمسح هذا 2 5. We don't want to look at that ugly thing. هني الانجل بيكون هذا الانجل theta, which is 68.2 degrees. تمام. Now we have all the angles, we have everything, we can find our moment due to both forces. Remember, what are we trying to achieve? We're trying to achieve that sigma moment is equal to 0, equilibrium. ما نبغى يكون في moment at all, right? We can start with the left side, looking at all the moments that is due to the left side. بعدين we look at all the moments due to the right side. وبعدين we will add them all up and they should all equal to 0, and then we can find our T tension. If we go through the step by step, هني بيكون عندنا هني ال Fy in this direction, وبيكون عندنا ال Fx in this direction. Alright. وهني بيكون عندنا let's call this Ty in this direction. وعندنا هني ال Tx in that direction. تمام. We know that Fy is equal to 5,000 cosine, and this is 5 kilonewtons, which is equal to 5,000 newtons. And then cosine 30, and it's adjacent. We know that Fx is equal to 5,000 sine 30, and it is opposite. And then, so this is going to be 2,500. And this is going to be equal to 5,000 cosine 30, 4,330. All right, newtons. انزين فحصلنا ال Fx وال Fy مالنا ال values. الحين we're going to look at the right side, ال T. We know that Ty, let me do it in the same colors. We know that Ty is going to be equal to, Ty is sine 68, فبيكون T times sine of 68, then it's opposite, sine 68.2 degrees. And then وعندنا ال Ftx, which is equal to T and then cosine of 68.2 لأن it is adjacent. Okay. فهني now we have all of this. Now we can find the moments. We need to know the perpendicular distance for each. For Fy, where's the perpendicular distance? This is the 90. The 90 is the perpendicular distance. And remember, we are trying to find this distance from O to the force. And then, so this is 90. And for Fx, if we just extend this line a bit more, this is the perpendicular distance, which is equal to 60 millimeters. تمام? Same thing on the other side. If we go from O to here, and then if we go from O up to this point, this is 120, and then, and for if we extend this line a little bit, this distance over here is also 60. So we have the dimensions of all of these. طبعا, if I want to write them in meters, I'm going to write this as 0.06 meters. I'm going to write this as 0.09 and 0.12, 0.09 meters, 0.12 meters, and this is 0.06 meters. Alright, فعندنا ال fx ال perpendicular distance حق fx fy and ty and tx. So we can find the moment of each. Alright, ال t we will look at it later. That's the value we're trying to find. فالحين let's do it one by one. So m moment of about O due to y is equal to, or I should say fy لأن الحين عندنا two things. Fy is going to be equal to 4,330 times the perpendicular distance كم كان 0.09 meters. All right, so this is going to be equal to 4,330 times 0.09, 389.7 Newton meter. And we need, very important now, we need to know the direction of this. How can we find out what the direction of Fy is? Again, like I said earlier, this is our O. Then we will extend this force until we reach O, and then we will go towards O. So in this case, we are going in this direction, صح? We're going towards O in that direction. So this is a counterclockwise moment, so it's negative. So this is going to be counterclockwise. I write all the directions in purple عشان ما يكون في confusion. This is the direction, which is counterclockwise. All right. So this is going to be counterclockwise. So it's equal to minus 389.7 Newton meter. Negative. Negative. We'll do the same thing again. How is it clockwise? If we do this Fy, and then Fy كذي. All right. هاي الساعة. هاي الساعة. الساعة يوم تروح تسوي تك توك تك توك هالصوب يروح. هذا clockwise. This one is going into this direction. So it's anti-clockwise. All right. Now, so this is counterclockwise, so it's negative. Then, so now we're going to look at the moment due to Fx, which is again 2,500 Fx times the distance, which was 0.06 meters. 6, which is equal to 2,500 times 0.06 meters, which is 150 Newton meter. Again, we need to check the direction. The direction is F is going this way. So if it's going towards O, it's going to go that way. So it's also counterclockwise. تمام? Then it's going to go downwards. لا? It's also going to be counterclockwise. So this is counterclockwise, which is negative. So it's equal to minus 150 Newton meter. All right? Now let us look at the other half, which is the T. So sigma moment of 0, about O, I mean, for Ty is equal to T sine 68.2. What's sine 68.2? It is equal to 0.93. Let's just write that from now. So it's 0.93. And then times the perpendicular distance. This is just the sine of 68.2. I simplified it. عشان there is no confusion, I'm going to write it actually here. So this is 0.93 T. All right. And this is cosine 68.2, which is 0.37. So it's 0.37 times t. And then, so again, the force Ty is equal to 0.93 t times the perpendicular distance for Ty, which is 0.12 meters. And then, if we simplify this, it's going to be 0.93 times 0.12, which is 0.11 t. Okay, and now we need to look at direction again. زين, we know that the direction of t is downwards. هاللي معطينا إياه في الصورة, so we know it's going to be downwards. So we know that these directions are correct. But let's look at ty. Ty الحين, if we are going to go down and go towards O, it's going in that way. So it is clockwise. So it is clockwise. So it is positive. So it's plus 0.11 t. زين. Again, I'm going to keep t as orange because that's what we're trying to find. And now we do the exact same thing for the moment around 0 for tx, which is equal to 0.37 t times the distance x, which is 0.06 meters. It's this distance over here, 0.06 meters, the perpendicular distance, which is equal to, if we just simplify the numbers, 0.37 times 0.06, it is 0.02 t. All right. Again, let's look at the direction. The direction is going here. And if we want to go towards O, we're going to go downwards like that. فبيكون, again, clockwise. So it's positive. So this is going to be clockwise. So it's positive. And then, so it's equal to plus 0.02 t. All right. Now, حصلنا all the equations, everything. Now we need to solve the actual question. Remember, the question من البداية كان يقول determine the magnitude where there will be no bending and zero moment. يعني احنا we're trying to find equilibrium. And then when sigma moment zero. يعني when we add all of these, they have to be equal to zero. فsigma moment الحين about O is equal to, we will write these one by one. So minus 389.7 Newton meter. ما بكتب اليونتس, we already know they're all Newton meter. زين, minus 150. زين, so this is coming from here. This is coming from here. Okay? Plus 0.11 t. This is coming from this one over here, 0.11 t plus 0.02 t. All right, we're just going to put them in all together with the units. This is coming from here. ويا البلس طبعا. And this will all be equal to zero because that's what we're trying to achieve, equilibrium and no bending. So if we simplify this, so it's going to be minus 389.7 minus 150. That is going to be equal to minus 539.7 plus 0.11 plus 0.02 is equal to 0.13. T is equal to 0. We will take the minus 539 to the other side. Yani this will just take it to the other side. For 0.13 t is equal to 539.7. And then, so t is simply going to be equal to 539.7 divided by 0.13. Therefore, t is equal to 539.7 divided by 0.13. 4,152 newtons تقريبا, or we can say 4.2 kilo newtons, and this is your final answer for T. So this is the value for T اللي نحتاجه احنا عشان ما يكون في bending in this mast head fitting. زين انه ما يكون يستوي اي bending يكنسل بعض البندنج كامل مال السؤال. As you can see السؤال مو بصعب, it's just long, there's a lot of math, a lot of calculations, a lot of understanding the distances, the perpendicular distances وين يكونون, ولكن في النهاية it is very straightforward, very easy الconcept. You just have to know how to apply it, you know, step by step عشان ما تخربطون. And yeah, that's pretty much it. توني لاحظت ان time is almost up, so I was hoping I would be able to finish all these questions, بس يعني there are too many. But again, the remaining questions, they might look complicated, but they're exactly the same idea. You might have extra forces given in multiple directions. It just takes longer to solve, but it is the exact same concepts. المهم أهم شيء you guys know إنه when you're looking at moment, you're looking at two things. Moment, you're looking at the force, and you're looking at the perpendicular distance. And then, the larger this distance is, the larger your moment will be. The smaller your distance is, and then the smaller your distance is, the smaller your moment will be. Moment will be equal to 0 when there's no force بالمنطق, or when the perpendicular distance is equal to 0 or doesn't exist. زين? This is the whole idea. Any questions about anything I've done so far until today? Inshallah, for the next sessions, I will be